So before we talk about the messages that neurons send, let's review a little bit about neuron anatomy. First of all, we have a motor neuron. Before the break, we talked about the different types of neurons. Sensory neurons and motor neurons have very different anatomy. Motor neurons are the most common, so we talk about them a lot. Remember that motor neurons send messages away from the central nervous system to your muscles and glands. The messages are received in chemical form by the receptors here on the dendrites. The neurotransmitters, which are the chemical messengers, cause a disturbance in the ions within the membrane of the neuron. Remember back in the muscular system, we talked about the knock on the door of acetylcholine? Acetylcholine is a neurotransmitter. Remember when sodium and potassium switched places? That is what I'm talking about when I talk about an action potential. The ions switch places all down the membrane, causing an action potential, a disturbance in the ions. Ions are pumped back and forth across the membrane, causing an electrical signal to travel down the axon. When the signal gets to the axon terminal, something magic happens. Let's look at the next slide. So as the action potential arrives, the vesicles, which contain neurotransmitters, fuse, become permeable, and fuse with the plasma membrane. These vesicles, like I said before, contain neurotransmitter molecules which are released into the synaptic cleft. Remember, the space between the neurons is the synapse, or the synaptic cleft. The neurotransmitters bind with the receptors of the receiving neuron. Where are we? These receptors are in the dendrites. Where are the neurotransmitters kept? They are kept in the axon terminal. You can see in the larger picture over here kind of the overall anatomy where the neurotransmitters are released into the synapse. The receiving neuron binds with the neurotransmitter and then releases it. An action potential is stimulated in the receiving neuron because the neurotransmitters, now look at this very carefully, the neurotransmitters cause the ion channels to open, allowing sodium to move into the membrane. Now let's look at the next slide for a close-up picture. So when sodium enters the membrane, it causes depolarization. So depolarized membrane allows sodium to flow inside the membrane. When those ion channels open, the membrane is considered depolarized. As I stated before, the exchange of ions initiates an action potential within the neuron. So as you can see, sodium is moving into the neuron from resting to a local depolarization, which is right here. Sodium moved in. The stimulus initiates a depolarization of the entire axon as the message moves away from the cell body. The myelin sheath, the covering of the neuron, allows the impulses to move faster. Now, immediately after depolarization, the neuron cannot receive another message until it repolarizes. So as the action potential moves down, the sodium and potassium switch places so that another message can be received.